So in section 2 of chapter 10, we're going to start to look at what are known as the conic sections in math. And a conic section is simply the cross section that we're looking at when we slice through what's called a double napped cone. A double napped cone is just two cones that are put together on their vertex. So these four pictures show the four different ways that you could slice through a cone and have these conic sections. So if your slice is parallel to one of the bases of the cones, then your conic section would be a circle. The second picture, if you kind of angle that slice but don't go through the base, that will be an ellipse, which is similar to a circle, but it's not the same distance in all directions. The third picture is a parabola, where you would slice through one of the cones and it would cut through the base. And then the last one is a hyperbola, where you slice through both cones and you have a parabola going in two different directions. So in this section, we're going to mainly be looking at parabolas, how to graph them, how to write the equation of parabolas given different information. So a parabola is the set of all points x and y in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus that are not on the line. The midpoint between the focus and the directrix is called the vertex, and the line passing through the focus is the axis of symmetry. Okay, so first we're going to look at a vertical parabola, which could open up or down. And the equation for vertical parabola is x minus h all squared equals 4p times y minus k. So everything in this equation has a purpose. The hk in the parentheses represents the vertex of our parabola. So that's always going to be its lowest point if it opens up and the highest point if it opened down. The axis of symmetry is x equals h, and that's what's going to cut our parabola in half. The focus is a point that's always on the inside of the parabola, and it's always p spaces away from the vertex. The directrix is a horizontal line on the outside that is always p spaces away from the vertex also. So the focus can be found at h, k plus p, and the directrix is at y equals k minus p. Okay, so now we're going to look at a horizontal parabola. Horizontal parabolas could open right or left, and the equation is y minus k squared equals 4p times x minus h. The vertex is still hk. The axis of symmetry this time is y equals k, and the focus is always p spaces away from the vertex, and so is the directrix. This time the focus can be found at h plus p, comma k, and the directrix is at x equals h minus p. Okay, so first we're going to look at a couple of examples on graphing parabolas. We want to find the vertex, axis of symmetry, focus, and directrix. So we want our equation to look like those two equations from the notes earlier. So we may have to do a little bit of manipulating or rearranging to get them to look like that. So this equation, y squared equals negative 6x, what I want to do is notice that there's not a number with the y squared. So I can rewrite that as y plus 0 all squared, and it doesn't change the value. Equals, on the other side, when I have 6 times x, that's really just the same as saying x plus 0. Even if I distributed the negative 6, it would get me back to the original equation. So those zeros are really there just to help me find all the little parts and pieces of my parabola. So since this is a y squared equation, I know this is going to be a horizontal parabola, and because the sign in front of the parenthesis on the right hand side is negative, that tells me this parabola will open left. If it was a positive 6 in front of the parenthesis, then it would open right. Okay, so since I know it's horizontal, we're going to start to pull out the information and use the information that I gave you earlier for horizontal parabolas. So we're going to start with the vertex, And the vertex is always h comma k. And you always go where the x is first and pull that number out and change the sign. Then go where the y is, pull that number out and change the sign. Now since these are zeros, 0 doesn't have a sign, so just 0, 0 would be the vertex here. Okay, next thing we want to know is the axis of symmetry. So since this is a horizontal parabola, the axis of symmetry is going to be a y equals equation. So it's always going to be y equals whatever the y equals of the vertex. So just y equals 0 in this case. So I'm going to graph these on my grid. So the vertex is at 0, 0. The axis of symmetry is y equals 0. Now I need to find the focus and the directrix. So to do that, you're going to take the number in front of the parenthesis on the right, the -6, and you always set it equal to 4p. So I divide by 4 to get p by itself, and p will equal -3/2. So what this tells me is that the focus is 3/2 spaces away in the negative direction of the vertex. Okay, so I go and graph this on my grid. I want to go 3/2 away, so that's like 1.5, and that's where my focus is. So my focus is at -3/2, comma 0. The directrix is always the same amount of spaces away from the vertex in the opposite direction. And the directrix this time is going to be a vertical line. Since my parabola opens left, it always opens, or the directrix is always in the opposite direction. So it's going to be at x equal 3/2. So we're going to draw a line over 3/2 spaces, or 1.5 spaces, and that's my directrix. My parabola always opens around the focus. It's never going to go through the directrix. Okay, let's do another example just like that one. So we've got x minus 1 all squared equals 8 times y plus 2. So this time, since it's an x squared equation, I know that it's a vertical parabola, and the sign in front of the parenthesis on the right is positive, so that means it's going to open up. Okay, so I'm going to start with my vertex. Vertex is HK, so you want to go where the X is first, then the Y, and always change the sign when you pull out a parenthesis. So this is going to be at 1, -2. Okay, then we do our axis of symmetry. Since this parabola opens up, my axis of symmetry is also going to go up and down. So that's an x equals equation, and it's always x equals whatever the x equals. So x equals 1. Then I need to find out how far away my focus and directrix is. So I set the number in front of parenthesis equal to 4p and solve for p. So p equals 2 this time. So that means our focus is 2 spaces away from the vertex, and our directrix is 2 spaces away. Since it opens up, our focus is going to be 2 spaces up, and our directrix is 2 spaces down. So after I've put them on the graph, that's when I identify what the ordered pair is for the focus at 1, 0, and then I know the equation for the directrix is y equals -4. So I always graph it first, and then I can identify what the equations are. Okay, so then my parabola is going to open around the focus. Okay, so some of the problems on your homework are not ready to graph as is. Some of the equations are going to take a little bit of work to get them to that point. So examples, that's what we're going to do. Figure out how we can manipulate the equation to get it in the right form. Then we can proceed and find all those things to be able to graph it. So the first thing I look for is what variable is squared. In this equation, y is squared. So anything with a y, I'm going to leave on the left-hand side. Everything else stays on the other side. So y squared minus 4y equals 4x. So this tells me that this is going to be a horizontal parabola. And so I want to get my equation to look like this one. Y minus k squared equals 4p times x minus h. So if you notice on the left, this is called a perfect square. Y minus k all squared. Well, right now we don't have a perfect square. So the way to get one, if you don't have one, is called completing the square. So to complete the square, we're going to be adding a number to the end of the equation on the left. Now in order to do that, I have to add it to the other side as well. So to know what to add to make this perfect square, you always take the number in front of y, and you're going to divide by 2 and then square it. So negative 4 divided by 2 and then squared will be plus 4. So if I plus 4 on the left, I have to plus 4 on the right. So the purpose of doing that is now I have what's called a perfect square trinomial. That when I factor this trinomial, it will become y minus 2 times y minus 2. On the right-hand side, I can factor 4 out of both of those terms. So that's going to be 4 times x plus 1. On the left-hand side, I can rewrite y minus 2 times y minus 2 as y minus 2 all squared, and then equals 4 times x plus 1. So now that it's in this form, I could find the vertex, axis of symmetry, focus, and directrix. I didn't do that on this problem. We're going to do it on the next one. I just wanted to show you how to complete the square. Okay, so same thing on number 4. I need to rearrange to get it in the right form. Then I can find the things that I need to graph. So look for what's squared. Keep it on the left, everything else on the right. So, x is squared. I know I need my equation to look like this. So, x squared minus 2x equals negative 8y minus 9. Anything with an x stays on the left, everything else moves on the other side. So I need to complete the square. I'm going to take the negative 2 and I'm going to divide by 2 and then square it. So negative 2 divided by 2 is negative 1 squared will be plus 1. So I have to add 1 to the other side as well. Okay, so then when I factor x squared minus 2x plus 1, this factors into x minus 1 all squared. If you need to do the other step first and do x minus 1 times x minus 1, then jump to this step, that's fine. Also, if you notice on the right-hand side, I did negative 9 plus 1 is negative 8. So now the only thing I need to do is factor out what's common on the right. So that would be a negative 8 that I need to factor out, which would leave me with y plus 1. So now that it's in this form, I can find all the stuff that I would need to graph this parabola. So let's start with the vertex. Vertex is hk. So our vertex would be 1, negative 1. My axis of symmetry, since this is an x squared equation, then the axis of symmetry is going to be x equals whatever the x equals. So that will be 1. I need to find out how far away the focus and the directrix is. So I set whatever is in front of parentheses, which is negative 8, equal to 4p. So it turns out that p is negative 2. So since it's negative, this is another indication this would open down. Okay, it's x squared, so it opens up or down, and then negative p is telling me that the focus is going to go down 2 spaces from the vertex. So if I'm at 1, negative 1, and I move down 2 more spaces, that means the focus is going to be at 1, negative 3. Then if I go back to the vertex and think about the directrix is a line that is 2 spaces above the vertex. So if I'm sitting at 1, negative 1, and I shift 2 spaces up, then that's going to be the line y equals 1. So then now I would have enough information to graph this parabola. Okay, so on example 5, we're going to start to look at how to write the equation of a parabola given a few pieces of information. And every one of these is going to be a little bit different because they could give you a lot of different things to solve for the equation. So they've given me that the vertex is at 0, 0, and the focus is 5/2, comma 0. So because I'm a visual person, I always like to draw a small picture just kind of as a guide to help me figure out where these things are located, what could this parabola look like, then that helps me make decisions on writing the equation. So if the vertex is at 0, 0, and the focus is at 5/2, 0, then my focus is going to be 2.5 spaces to the right of the vertex. Okay, so then that would mean also that my directrix is 5/2 spaces in the opposite direction. So that would be 5/2 spaces to the left. Okay, then I know that my parabola opens around that focus, so that tells me that this is a y-squared equation. This is horizontal. So now I'm going to plug in the pieces that they gave me. So y minus k squared, that's going to be part of my vertex, equals 4p times x minus h. The p is the distance from the vertex to the focus, so it's 5/2 spaces away. So I'm going to do y minus 0 squared equals 4 times 5/2 times x minus 0. So then we're just going to go through and simplify. Y minus 0 squared is just y squared equals 4 times 5 over 2, which will be 10 times x. So this is the answer that I would leave. If I was wanting to graph this, I don't have the ability to graph y squared in my calculator. I would have to get y by itself by taking the square root of both sides. Then when I take the square root, remember you have to put the plus or minus square root of 10x. So the positive square root would graph the top and the negative square root would graph the bottom. So we don't need to do that on this problem. I just wanted to show you that that's how you could graph this problem. But what we were looking for is y squared equals 10x. Okay, so now number 6, this is actually number 15 from your homework. So this one, the focus is at 121 over 12, comma 2, and the directrix is x equals 119 over 12. So again, I'm going to sketch a little picture just so I can visualize what direction this might be going. So if I graph my focus, 121 over 12, comma 2 is a little over 10, comma 2. So just imagine I went past 10 and up 2. And then my directrix is at 119 over 12, which is a little over 9. So pretend I go over 9 and I draw my directrix. Well, I know that my vertex is going to be halfway between the focus and the directrix, and the parabola opens around the focus, so that means my parabola would look something like this. So I know it's going to be a horizontal parabola, which is a y-squared equation. So when we get to plugging in a minute, that's what we want to plug into. So first thing, I need to find the vertex, and I just said that the vertex is halfway between the focus and the directrix. So basically, we're going to find an average of the focus and the directrix. So that's what this is. 121 over 12 plus 119 over 12 divided by 2. That will give us the midpoint of the vertex, okay, which is halfway between the focus and the directrix. Okay, so if you do that divided by 2, then you get 10. Works out really nice. Now, all of these points, if you notice, we went over a certain amount, and the focus and the vertex are going to line up along the same line. They're both going to go up 2. And if you imagine that axis of symmetry that goes through there, that's another way that you would know that they both go through 2. Okay, so then I need to find out P, the distance from the focus to the directrix. So to find that distance, we're going to say the focus value, 121 over 12, minus the vertex value. We're just going to find the distance between the two. And if I do 121 over 12 minus 10, this turns out to be 1/12. So now that I have my vertex and my p-value, I can plug into y minus k squared equals 4p times x minus h. So this is going to be y minus 2 squared equals 4 times 1 over 12 times x minus 10. So the only simplifying that I would want to do is 4 times 1 over 12. So this turns out to be y minus 2 squared equals 1/3 times x minus 10. So this would be the equation of this parabola that opens to the right and has a focus and a directrix with the given information. Okay, last one. We're given the vertex is at 3, -3, and this parabola goes through the point 0, 0. So if I think about a picture, 3, -3 is the vertex, and it goes through the point 0, 0. Now they're also going to give you information on this type of problem on sort of a hint about what direction it opens. And the hint for this one is that it opens up or down. So the only possibility for this to work, for it to go through the vertex and through that point 0, 0, is it has to open up. So that means that this is an x squared equation. This is a vertical parabola. So we need the vertex. We have it. That's our HK. We don't know P. They didn't give us any information about the focus or the directrix. But we gave this point 0, 0, which is an xy coordinate. So I'm going to plug all 4 of these numbers into the equation and solve for the missing variable, which will be p. So if I do that, 0 minus 3 squared equals 4p times 0 plus 3. So 0 minus 3 squared is 9 equals 4p times 3. So that means that 9 equals 12p, and p equals 9 over 12, which is 3 over 4. So now that I have my p and my vertex, I can plug into the x squared equation. So that's going to be x minus 3 all squared equals 4 times 3 over 4 times y plus 3. So when I multiply 4 times 3 over 4, then that's going to give me x minus 3 all squared equals 3 times y plus 3.